Well, today we're going to go for a tour inside its brand new headquarters.
Chinese company's headquarters look 100 years ahead. American engineers are shocked. You're about to see corporate headquarters that look like they were pulled straight from the year 2125. While much of the world is still stacking glass boxes, China's tech giants are building gravity-defying loops, floating towers, and structures that twist skyward like strands of DNA.
Wow, what is this? Spring bamboo suit.
These aren't concept renders. They're not futuristic fantasies. They're real buildings, operational headquarters where hundreds of thousands of people go to work every day. This is architecture that doesn't predict the future, it arrived early. Here are 12 headquarters proving the future of design is already here, and it begins with a building that literally challenges gravity itself. DJI Sky City, Shenzhen. Two glass towers seem to hover above the city, suspended in mid-air. DJI Sky City looks exactly like what you'd expect the world's largest drone manufacturer to build, a headquarters designed to fly. Massive cantilevered volumes jut outward with no visible support, creating the illusion of weightlessness. But appearances deceive. Supporting thousands of tons of glass and steel, and concealed central core redistributes loads through an invisible steel exoskeleton, allowing the towers to extend outward while appearing to defy gravity. Even more astonishing, drone testing facilities are integrated directly into the building itself, 9 stories above ground. Drones don't just operate here, they move through the architecture. This building doesn't merely house drone technology, it behaves like it. And floating towers were only the beginning of Shenzhen's architectural revolution. Tencent headquarters, Shenzhen. 2 skyscrapers rise 820 feet into the skyline, leaning toward each other as if mid-conversation. Suspended between them are sky bridges that appear to hang in thin air. Together, the twin towers house more than 50,000 employees, forming a complex that feels alive, constantly in motion. But connecting 2 independent skyscrapers is an engineering nightmare. During typhoons, each tower sways on its own rhythm. The solution? AI-powered structural systems that respond in real time. The sky bridges use advanced expansion joints, allowing both towers to move independently while remaining seamlessly connected. These bridges aren't simple walkways. They're floating collaboration hubs, gardens, meeting spaces, and social zones suspended 800 feet above the ground. Smart climate systems cut energy consumption by 40%, turning the entire complex into a self-optimizing machine. This isn't 2 buildings linked together, it's one intelligent organism designed to think, adapt, and evolve.
Huawei Oxhorn Campus, Dongguan. Huawei didn't build a headquarters, it built an entire city disguised as one. Sprawling across 4.6 million square feet, the campus unfolds through buildings shaped like sweeping ox horns, curving naturally across the landscape. In total, 120 individual structures are woven into a single unified complex. Inside it are 12 European-inspired towns, recreated street by street within one corporate ecosystem. This isn't a workplace, it's a small country. But scale creates problems. How do you connect 120 buildings without chaos? How do you move nearly 100,000 employees across a campus that stretches for miles? How do you keep operations efficient when your headquarters is larger than some cities? Huawei's answer is infrastructure. An autonomous internal train system runs over 7 miles of track, linking every district seamlessly. Advanced green building technologies cut energy use by 30% across the entire campus. And the iconic oxhorn curves aren't just visual flair, they're engineered to optimize airflow and enable natural cooling, reducing the need for mechanical systems. Huawei didn't design an office park, they engineered a fully functional city that just happens to design smartphones. From sprawling corporate metropolises to gravity-defying towers, this is what the future of headquarters looks like. Oppo headquarters, Shenzhen. The O Tower rises above the city as a flawless ring of glass and steel.
Oppo didn't just brand their headquarters, they built their logo at skyline scale, a perfect circle with a hollow core, hovering like a futuristic halo over Shenzhen. It's one of the boldest geometric statements in modern architecture, and one of the hardest to execute. Circles create engineering nightmares. How do you design usable interior space when there are no straight walls? How do you support a massive ring without a central column? How do you manufacture thousands of curved glass panels when not a single one is the same? The solution was precision engineering. A continuous structural system distributes weight evenly along the entire circumference, transforming the circle from a weakness into a source of strength. An intelligent facade tracks the sun throughout the day. Every curved glass panel was individually modeled and fabricated using parametric design software, customized down to the millimeter. What looked impossible on paper became remarkably efficient in reality. The ring doesn't just stand, it performs. And just when it seems like Shenzhen has reached the limits of architecture, the city reveals what comes next.
Ping and Finance Center. 1,965 feet straight into the clouds. China's fourth tallest skyscraper rises over Shenzhen like a steel needle, a tapered giant piercing the skyline. Inside, more than 15,000 people work daily, inside a building that moves in winds most structures never encounter. At nearly 2,000 feet, you're no longer fighting gravity, you're fighting typhoons. How do you keep a tower stable when wind forces at that height can twist steel? How do you stop workers from feeling motion sickness on the upper floors? How do you anchor something this tall to the earth itself? The answers are buried deep in engineering. Over 1,700 tuned dampers are embedded throughout the structure, absorbing wind energy and neutralizing sway before it's ever felt. The tower's tapered form reduces wind resistance by nearly 40% compared to straight-sided skyscrapers. Beneath it all, the foundation drills 180 feet into bedrock, deeper than the building is wide, locking the tower to the planet. Smart building systems cut energy consumption in half. This isn't just height, it's dominance over physics. And Shenzhen's skyline wasn't finished growing. China Resources Tower. 1,280 feet of flowing curves inspired by bamboo shoots breaking through the ground. This tower doesn't fight the sky, it grows into it. Its organic, non-linear form makes the building look alive, as if it's still unfolding. But curves at this scale are structural insanity. How do you design a glass facade with no repeating patterns? How do you support asymmetrical forms hundreds of meters above ground? How do you hide the steel skeleton needed to keep it standing? The solution is a diagrid system, a network of diagonal steel grids that distributes loads efficiently while remaining invisible beneath the bamboo-inspired exterior. The curves aren't decorative, they're aerodynamic, reducing wind stress naturally. Adaptive facades and passive ventilation push energy efficiency 30% beyond code requirements. Form and function merge into a living sculpture, one that happens to house thousands of workers. But Tencent had one more vision waiting to twist into reality.
Tencent Helix. Two towers spiral toward the sky like intertwining strands of DNA. The Tencent Helix doesn't simply rise, it twists. A true double helix structure, with each tower wrapping around the other in a continuous curve that ignores every rule of traditional construction. And that's the problem. Twisting buildings want to tear themselves apart. How do you keep spiraling towers stable when the floor plates change shape on every level? How do you connect two rotating structures without breaking either one? How do you build something with almost no straight lines? The answer is structural genius. A double helix steel framework allows each tower to support the other through the spiral itself. The twist isn't decoration, it's load-bearing. Green terraces climb the exterior, following the curve skyward. Nothing repeats. Every beam, every joint, every floor plate was custom engineered from scratch. Innovation, literally twisted into steel. From biological inspiration to geometry that shouldn't exist, Beijing took things even further. CCTV headquarters, Beijing. two towers lean toward each other at impossible angles, then lock together at the top with a 90-degree cantilever hanging 525 feet above the ground. The CCTV headquarters looks like a building frozen mid-collapse, a loop of steel and glass that defies instinct. At 768 feet tall, this isn't construction, it's a physics experiment. How do you assemble a horizontal overhang 50 stories in the air? How do you distribute 550,000 tons across a structure designed to look unstable? The solution was revolutionary. A diagrid steel system, a dense lattice of diagonal triangles that spreads forces across the entire loop. Every joint was individually analyzed, every stress calculated. 6 years of relentless engineering turned the impossible into reality. The building everyone said couldn't be built became the building that redefined skyscrapers. Gravity didn't win, engineering did. And while Beijing got impossible loops, Hangzhou went in a completely different direction. Oppo headquarters, Hangzhou. This building doesn't stand still, it flows. Glass curves wrap around the structure like water frozen mid-motion. Unlike Oppo's circular Shenzhen tower, this headquarters feels alive, shaped by movement rather than geometry. But curves in every direction create chaos for engineers. How do you maintain structural stability when no surface is flat? How do you fabricate 12,000 glass panels when every single one is different? How do you make liquid architecture earthquake resistant? Advanced parametric design software mapped every curve mathematically. Each glass panel was digitally modeled and custom fabricated with millimeter precision. Beneath the flowing skin, diagonal bracing flexes with the curves while maintaining seismic strength. It looks soft, it's engineered to survive disasters. Infinitus Plaza. This isn't just a headquarters, it's a health experiment at architectural scale. LEED Platinum certified from day one, Infinitus Plaza was designed to make 8,000 employees healthier simply by being inside it. Air quality exceeds hospital standards. Natural light reaches 80% of workspaces. But making sustainability work at this scale is brutally complex. How do you recycle water for thousands of people? How do you cut waste by 90%? How do you turn green promises into real performance? Advanced filtration systems recycle nearly all water on site. Smart sensors constantly monitor air quality in every zone. Adaptive glass tracks sunlight throughout the day to optimize comfort and efficiency. The building itself became healthcare technology. Infinitus didn't just build green, they built a structure that actively improves human life. And then, someone decided to ignore subtlety completely. NetEase Games headquarters. A full-scale starship parked in the middle of a Chinese city. This isn't inspiration, it's literal. The headquarters is shaped like the USS Enterprise, saucer section and nacelles included. It's possibly the boldest corporate building ever attempted. But turning science fiction into usable office space isn't fun in games. How do you make a spaceship structurally sound? How do you turn fantasy shapes into real load-bearing systems? How do you convince engineers this isn't madness? Hidden beneath the sci-fi exterior is serious engineering. Radial steel beams spread loads from a central core. The nacelles are real buildings, connected by reinforced skywalks. Every curve hides structural logic. It stands. It works. People clock in and do real jobs inside a building that looks ready for warp speed. This proved one thing beyond doubt. Corporate architecture doesn't have to be boring. It just needs engineers brave enough to try.